Welcome to aminacademy.com in mathematical economics regarding constraint optimization with Lagrange multipliers. Let us do some solving problem. Look at this example. Use the Lagrange multiplier to optimize the following functions subject to the given constraint. Look at here. Here f of x comma y comma z equal 5xy plus 5xz plus 3yz subject to constraint to xy z equal to 1920. Also estimate the effect on the value of the subjective function for a 1 unit change in the constant of the constraint. Look at here. First, we have to write the given equation. That means we have to optimize this function with subject to this constraint equation. First, let us write the given equation. F of x comma y comma z equal 5xy plus 5xz plus 8 plus 8xz 5xy plus 8xz this is 8xz and 3yz. Then we know that constraint equation subject equation is to, therefore combining the subject equation here, subject to is subject is 2xyz 1920. Look at here. From this we can get 1920 minus 2xyz equal to 0. Then therefore the function combined function become capital F is 5xyz plus 5xy yxy plus 8xz 8xz plus 3yz plus lambda is a multiplier, Lagrange multiplier of this constant function 1920 minus 2xyz equal 0. And this by partial derivative fx dou x by dou f by dou x. Here partial derivative with respect to x is here 5y plus 8z. Here this yz becomes 0 because there is no x term. This is lambda minus 2xyz, so which is equal lambda yz minus 2 lambda yz. Look at here, lambda into 2 into lambda 2 lambda xyz subject with respect to x differentiation is 2 lambda yz. That will be this equals 0. Equation 1. Similarly, fy partial derivative with respect to y gives here this one is 5x. This will become 0 because there is no y terms here, plus 3z and the same here minus 2 lambda xz equal 0. That will be equation 2. Similarly, partial derivative with respect to z equal here this no z term becomes 0. This z term, that is plus 8x plus 3y with respect to z is 3y minus 2 lambda with respect to z is 2xy. 2 lambda xy equal to 0, equation 3. Look at here. From all the equation you can get lambda. From 1, look at here. From 1, this other side 2 lambda yz. So lambda equal to 5y plus 8z. Lambda equal 5y plus 8z over 2yz. From this, we are divided by 2z throughout. It becomes 5 over 2.5 over z. Here, this division 8zy 2yz is 4y. 4 over y. Then let it be 4. Like this, from 2 gives lambda. Same 5x plus 3z over 2xz, which gives 5 by 2 is 2.5 over x cut z plus 3 by 2 is 1.5 over x. This equation 5. Then from the equation 3 lambda, that means here this 8x plus 3y over 2xy equal 4 over y. 8 by 4, 3 by 2 is 1.5 over x. This equation 6. We have lambda values in different forms. From the, look at here, first 4 equal to 5 because both are lambda values, equating 4 equal to 5, which gives these two lambdas are equal, means 2.5 over z plus 4 over y, which is equal 2.5 over z plus 1.5 over x. Now this 4, that is 2.5 over z, 4 over y. This one is 2.5 over z plus 1.5 over x. With both equating 2.5 over z plus 4 over y, which is equal to 2.5 z plus 1.5 over x. 1.5 over x. Here, from this, we can understand this 2.5, both sides cut. So we have 4 over y equal 1.5 over x. From this, x is equal, by cross multiplying, 1.5 over 4y. Now, another set, then equating 5 and 6. Because both are equated lambda, 5 is equal 6. Here, 5 tells as 2.5 over z plus 1.5 over 2.5 is plus 1.5 over 1.5 over x equal 4 over y plus 1.5 over x. These two terms cut, so we have 2.5 over z equal 4 over y. From this z we can get in 2.5 y over 4. We have two values. This, look at here, we have x value and z value. Then we can substitute x value and z value in equation. Here 1920 minus 2xy z equals 0. The equation 1000 now the equation 1920 minus 2xyz, that this equation 1000 and 2xyz equals 0 is, we are having that equation. Substituting the values x and y. X is what? 1 over 5 by 4, that is 1000 into x value we have 1.5 over 4y, 1.5 over y, 1.5, no, 1.5 into y, 1.5 over 4 into y. Then z value is 2.5 over 4 y equals 0. Therefore, we have 2 into 1.5 over 4, 2.5 over 4. X values, what is x value? X value is 1.5 over 4 y, and z so 2 into x value is 1.5 over 4 y, then y value, y is y, one more y is there here, y into 2.5 over 4 into y cube equal 1920. Then from this we get y cube equal 4096 by calculation. We have y cube this much. From this we can get y equal cubic root of 4096 equal 16. Therefore, the critical values we can find. Therefore, that is x0. X0 is in terms of y. What is x0? 1.5 divided by 4 into y. 1.5 y is 16, which is equal 4 into 1.5 is 6. Then y0 is 16. Z0, then Z0 is 2.5y over 4. 2.5 over 4 into y. That is 4 into 2.5 is 10. So we got x0 is 6, y0 is 16, z0 is 10. Therefore, our function and also by using these three values we can get the lambda. That means by using any one equation, suppose equation 1 we use it, 5y. Equation 5 tells from first equation 5y plus 8z minus 2 lambda yz. From equation 1, 5y plus 8z plus 8z minus 2 lambda yz plus 2 lambda yz plus lambda yz equal to 0. Substituting the values, y into 16 plus 8 into z is 10 plus 2 lambda y is 16 and z is 10. Then we have 30 plus 80 plus 160 into 2 is 320. Then lambda value is lambda value, you can get it minus here, sorry, here this is minus, so this also minus. Then for lambda equal 30 plus 80 over 320, 110 over This is 80, sorry. This also 80, this also 80. So 160, which is equal 0.5. We have lambda equal to 0.5. So then we got the all values. That is 8x plus the function is here. If you put this all values, we can get it. So we got all values. Then we have to find so we have not always multiply the following functions subject to given constraints. We got then look the second things. Then optimize the function. This phi xy, we have to substitute this point, this xyz values here. We can get maximize the, we'll get the maximize the function. That is f equal 0.5. This is therefore function is f, the function what is the function f is subject phi xy plus 8xz phi xy phi xy plus 8xz plus 3yz plus 3yz. So we have to substitute the values. Y into x value is, we have x value is 6, y is 10, y is 16 plus 8 into x is 6, z is 10 plus 3, y value is 16, z equal to 10. So we have a set of values 480 because 5 into 16 is 80, 80 into 6 is here, also 480, here also 480, which is equal 0 to 8 plus 8 plus 8 is 24, 2, then 140. This is the maximize the values 1440. Also look at here, if lambda is increasing 1 unit, also find estimate effect the value of objective function unit 1 unit change in the constant of constraints. The lambda becomes 1 unit, this becomes the lambda increases the 1 unit, then the function become increases, that is 1440 plus 1.5. Already lambda, we have put 1.5 here, 1.5, because already lambda is 0.5, it increases 1 unit, it becomes 0.5, 1.5 with the increase of 1220. Now that becomes easily, you can say, increase of 120. There's more increase of that function, constraint function, 1000 minus 2, that's why z. So the value becomes more, that means 1440 plus 1.5, 1000 minus 2 into, what is x? X is 6, y is 16, and z is 10. So which is equal 1440 plus 1.5, 1920 minus 2 into this much. We'll calculate the values of this here. 16 to 16, 96, 96 into is 10, 96 into 192, 0, this 192, 0. Yeah, this function f becomes like now. So that is here the multipliers increases, this having this value is 1440. So far we discussed about Lagrange is optimizing the function by using Lagrange's multipliers. We have done. Please subscribe our YouTube channel.